Welcome to LupoScan Tutorial 5. In this tutorial, you will learn how to create an orthophoto, a true-to-scale image relative to a projection plane. First, download the data for this tutorial from the link provided in the description of the video. Then, import the data into LupoScan by dragging and dropping the folder containing it into the left section of the screen. Open both laser scans and arrange them side by side by pressing the Tile Vertically button. You will notice that a section of the back wall is hidden by a pillar in each scan. Close Scan 6. As explained in Tutorial 1, Step 5, a projection plane must be defined to calculate an orthophoto. In this example, the projection plane will be created with greater precision using the Adjusted Plane dialog. Open the Adjusted Plane dialog and enable the Region Grow feature. Set the tolerance to 2 cm and adjust the increment to 5 using the mouse wheel. Activate the Determine Individual Points button and select one point on each side of the pillar on the back wall in Scan 7. Click Calculate. With Region Grow activated, LupoScan will search for all points with an increment of 5 that lie within a tolerance of ± 2 cm to the adjusted plane. The adjusted plane will be fitted incrementally to the newly found points. After the calculation, the identified points will be displayed in the selected color in the 2D view. Use the Insert button to add the calculated adjusted plane to the 3D view, then close the dialog and Scan 7. To better understand where the plane lies, visualize Scans 6 and 7 as a point cloud. Open the Point Cloud dialog, set the increment to 10, check the Multiple Files option, and select both scans. Click Start, and then close the dialog. Adjust the visibility of the point cloud if needed. If not already opened, open the Object Manager. Activate the Determine Individual Points button and click on the plane to see its attributes. Enable the Labeling checkbox to view the 4 corner points of the plane in the 3D view. Ensure the points are in the correct order, otherwise orthophoto may be created mirrored. From the viewer's perspective in the 3D view, P1 should be in the top left corner, P2 in the bottom left, and P3 in the bottom right before the plane can be used for orthophoto generation. You see that in this case, the point positions are correct. However, if they appear differently, select the plane, click the Properties button, choose Plane Align, press Start, and confirm with OK. Alternatively, you can adjust the point order using the Mirror and Rotate buttons. Align the plane vertically by pressing the Verti button. Notice how the omega and kappa angles change. Adjust the dimensions of the plane by setting its width to 7 and its height to 6.4 to ensure the entire wall is included in the projection. Open the Orthophoto dialog. As you may remember from Tutorial 1, You have already created orthophotos in LupoScan using Quick Orthophoto. That dialog uses the similar parameters, which are explained in detail in Tutorial 1, Step 5. However, this dialog is more advanced. For example, you can create an orthophoto from a large number of scans that you can select and add into the dialog in several different ways. If you frequently use a specific set of parameters, you can name and save it for later use. Activating the Open New Files checkbox opens the newly created orthophoto. Unless already active, activate the Determine Individual Points button and click on the plane in the 3D view. When you click the Transfer from 3D View button in the Orthophoto dialog, the corner points P1, P2, and P3 of the plane will automatically be transferred into the Orthophoto dialog window. By clicking the Ortho Box button, the front and back space and the projection plane will be shown in the 3D view. Every point in the point cloud that falls within the Ortho Box will be used in the orthophoto calculation. Using the grips, which you can click on and drag, you can adjust the projection area. Additionally, you can modify the size of the plane. The depth of the green and red areas can be entered as a number in the dialog, where the field front space stands for the green area and back space for the red area. Enter 2.6 in front space and 0.4 in back space. Click the Ortho Box button to see the updated dimensions in the 3D view. Select the laser scans 6 and 7 using the Add One or Several Files button. Change the parameters in the Orthophoto dialog as follows. Ensure Front is active. This means you can choose whether the front or rear point cluster is used for the calculation of the orthophoto. Set the maximum distance to 5 mm. The maximum distance specifies how far point clusters can be from each other to still be considered a single cluster. If the distance between clusters is greater than this value, the nearest or farthest cluster will be used for the projection, depending on whether the front checkbox is active. In sampling type, select NN, which stands for nearest neighbor. Set the resolution to 1 cm. If the resolution is set too high, there will be gaps in the orthophoto. Set the resolution Z to 1 mm. This value specifies the smallest unit for depth information in the orthophoto and should approximately match the accuracy of the laser scanner. Activate Edge View to create an additional view that highlights edges. Check the Merge checkbox to combine data from all selected scans into a single orthophoto. Also, check Single to generate individual orthophotos for each scan. In the Name field, enter Orthophoto. Activate Open New Files to open the orthophotos automatically once generated. Press Start. Three orthophotos are generated: a merged one made from both scans and individual orthophotos for each scan. Close the 3D view and arrange the orthophotos side by side by pressing Tile. In the merged orthophoto, the pillar is mapped completely because the front checkbox was active. Now, create an orthophoto where the back wall is displayed entirely. Close both orthophotos made from scans 6 and 7. Back in the dialog, uncheck Front and Single. Change the name to Orthophoto B and press the Start button. The new orthophoto shows the entire back wall. This is even more apparent in the spotlight view. Right-click on the orthophoto and select Create Spotlight View from the Context menu. Close Orthophoto B and set the remaining orthophoto to Intensities view. You can export orthophotos in many different formats. In this example, we will export it as a TIFF file. To do this, press the Save button and change the format to TIFF-Image. Use the double slider to adjust the intensity values according to your needs. The selected values will automatically populate the I-min-max fields in the Export dialog. You can also choose to export specific view modes, which are explained in detail in Step 5 of Tutorial 1. Press Start to export the file. A new entry will appear in the file bar. Note that the I in the file name indicates intensities. Orthophotos can also be sent directly to various CAD software programs. Click the Send Orthophoto to CAD button and add the open orthophoto by pressing Add Active window. Before proceeding, ensure that LupoScan is connected to the correct CAD software version by navigating to Settings and selecting the version that you use. We will send the Intensities view along with the Edge view, which we had previously checked to be created in the Orthophoto dialog. Both views will be inserted true to scale on separate layers in the CAD software, positioned correctly. Take a moment to review the Edge view. Finally, you can send both the orthophoto and the projection plane to the 3D window for further analysis. To do this, right-click on the orthophoto and select Orthophoto to 3D and Plane to 3D, respectively.